Hello, sir. Is this
Yeah.
the only question? I wasn't here. Like my internet went out.
No, it's all right. I understand it. In that case, it's all right. Go ahead.
So, sir, is this the only question?
This is the only question. Have you answered?
Yes, sir.
Yes,
I
sir.
sent
Almost,
it
almost
You,
by
complete.
you
email.
just, if you complete, you just know what to do, right?
Yes, sir.
Just send it to me at my email address.
Already sent.
Okay,
Okay,
then
sir.
you just, okay, then just wait. Let everybody finish it and then you can go. Now another 4 minutes to go. Three minutes to go. Yes, hello. Excuse me, your time's up, and you hope started sending it by email. It's now 46 already, so another 4 minutes to go. I receive your email. Okay, if any one of you wants to know here to confirm your sending the email. Okay, go ahead. I'm going to tell Noshin here.
Yes, sir.
Noshin,
Sent
I
it.
received. Yeah, I received your Fabiha Khan.
Yes.
Fabiha Khan, I received it.
Yes, sir. Yes, sir.
Lubaina Hawk. Hey, Lubaina.
Yes, sir. Yes, I
Okay,
sent.
I'm just telling your name. Rubaina Hawk, I received it. And Lubaina Hawk. Farhan Tasnim Tanmoy, received.
Yes,
Isha,
sir.
yeah, Isha Tarek Islam, received.
Yes, sir.
Jihad bin Saad, received.
Yes,
Yeah,
sir.
okay, good.
Yes, sir.
Then Muhammad Sadman Sakib Kabbo, received. Sajjad Hussain, I received. Now next, rest of you are sleeping. Are sending, already sent. Anyone else?
Yes, sir.
Up to Sajjad Hussain, I received.
I am sending, sir.
Okay, if you delayed or
Sir,
any problem, call me at my mobile. I told you. Otherwise, I will not consider you. Just reduce the marks.
I have already sent it, sir.
Yes, sir. That one. What's your name?
Sir, Burhanuddin, sir.
Okay, I think it will be coming then. Just wait. I'll call your name if it comes.
Sir,
No, sir. Nobody talk. No,
I-
unnecessary talk. I don't want to listen. We want to finish first up to 450. Then we will talk about anything. Just let's see that everybody can send it in time. Okay, Burhan, I did not receive it yet. Maybe I think it is coming on the way. Just a minute. I think, yep, that may be a reason. Everybody start sending. I'm just refreshing my browser so that I can confirm the rest of you. Okay, up to Sajjad Hussain, what I told, I received. And I'm going to refresh the browser and let you know who other guys had sent. And let's see who cannot send. There will be questionable why. Okay, let's see. Yep, I have a lot of email I got already. Now I'm going to read now. After Sajjad Hussain. After Sajjad, it is Lubaina Hawk, I think. Lubaina, you send me twice or what? Don't send twice. Okay, and Burhan.
Sir, I mistakenly sent it twice.
Okay. Anyway, I don't know. And okay, Burhan.
Yes, sir.
I received your one. Kamrul Islam Labib received. Anam Al Ahad. Imamul received. Emon Chaudhary received. Muntasir Ahad received. Gaurav Shah received. Then Hidayatul Islam, yes, received. Okay. Anyone else did not read the name? Anyone else name? 49, another 1 minute to go. Hey, are there anyone here whose name I did not call? Okay, Shaumitra Kumar Shaha just received. Shaumitra.
Sir, I have
Yes,
also
sir.
sent.
Yeah, I have also sent, but you didn't.
What is your name? Who are you?
Sir, Akib.
Or no?
Arnav, I think I did not call your name, right?
Yes, sir.
Okay, and Akib, I did not call your name.
Yes, sir.
Okay, 2 of you.
See, even I can.
And anyone else that I did not call name?
Yes.
Who?
Sir, I'm Nafis. I didn't call my name.
Okay,
Firzad
nothing.
Osman.
But you send it.
Yes,
Yes,
sir. I just sent
Okay,
it
okay.
now.
Then oh, now then it will come. Just a minute. Okay.
Sir,
then-
Zawata.
yeah, Jawata. I'll refresh it again. I think I remember Shaumitra Kumar Shaha. Up to Shaumitra, I have received. I'm going to give another refresh of the browser and let you know. Okay, Shaumitra. Okay. Shaumitra, then Shamanti Rahman, then Rohit. What is Rohit Shil? Rohit Shil. Hey, Rohit, are you here? Who is this Rohit Shil? Okay, and Amatashur. Is it Amatashur?
Sir, that's me. That's me.
Okay. Another one is Jawata Afrin. Jawad Jidan. Then
Yes, sir.
Abhi Chaudhary. Then Amatashur, why you are sending twice? Okay. Then Bipro Bhattacharya. After Bipro Bhattacharya, Sadman Sakib. Hey, Sadman Sakib Kabbo, you are sending twice, is it?
Yes, sir. Because I sent first one is the PDF format. That's why I send it again.
Okay, making trouble. Okay, Kabbo, and then Kamrul Islam Labib. Yeah, we received your one. I hope that all of you heard your name or anyone else left.
Sir, I didn't heard my name actually.
What is your name?
Still name. Arnob, sir.
Ornob. Ornob, are you which? I think I called one name Amit Tushar. Are you that
No,
guy?
sir.
Okay.
No, sir.
Then you sent the email from Rohit Shil. Are you
No,
Rohit?
sir. Arnob 667799.
Oh, your email. Okay, name is there. Arnob. Okay. Then when you send it, 1,000 years ago or just now?
No, sir. No, like 50 in 950.
Okay,
Sharp
just let me
950.
check. Okay, let me check. Arnob.
I actually replied one of your mail. That's why I guess.
Why you could not send a separate mail? You have to pay money for that, is it? Okay,
Sorry,
just
sir.
a minute. I could not get it yet. Okay, Arnob, can you resend a fresh? Oh, yeah, Amal Paul. Hey, Amal Paul.
Resend it, sir.
Who is that? Amlan Paul.
Amlan Paul, yes, sir.
Yeah, I received it. Now, Arnob, is it
Yes, sir.
Arnob? Amlan Paul is Arnob now.
No, sir. No, sir.
Okay, Arnob, I did not receive you. I have refreshed, but I didn't. Can you resend it faster?
Yes, sir. Yes, sir. Okay.
Waiting for another friend to copy.
No, sir.
Resend it faster now. Okay, any other than Arnob, are there anyone else whose name is not called? Hey, everybody's name called? Hello?
Yes, sir.
Okay, fine. I assume everybody's name is called except Arnob. Arnob, still you copying from your friends, right?
No, sir. I already sent it, and I had to just click the pictures and then send it to you.
I'll check your script with everybody 1,000 times.
Yes, sir.
And
Sure.
if it is, I see, then I'll call you and that fellow in a viva. And caught means you will be in trouble. Okay,
Yes,
now
sir.
let's come back to the point. I didn't get it yet. Your email. Have you sent it?
Yes, sir. I'm just sending it, sir.
Or you are sending? That's why I'm telling you. Did not complete your copying.
No, sir. Actually.
Okay, I
Fine.
got caught. I'll reduce your mark automatically because you are already out of time.
Sir, but I sent it before, sir.
Okay, if
If you
it is
just check
sent,
your,
as I said, come on. If you send it before, you forward that email. I'll see the time over there.
I'm also doing that, sir. And I
Yeah,
also
that's
sent
good.
it-
Then it's all right. Then it's all right. If you can do that, all problems solved. Do it faster. Okay, Arnav, I didn't get it yet.
But I sent it, sir.
Okay, you send it now. You are.
And I send you the previous
Shams
email, actually.
Oh yeah, Shams Firdaus Arnav, right?
Yes, sir.
All right, now it comes. All right, no problem. So I got everybody's email, I hope, and the exam is over. So we can take it off from here. All right, so that should be fine. Now we are jumping to today's class. Before going to today's class, I'm just giving you 2 to 3 minutes time. Just can you hear me?
Yes, sir.
Okay, now listen. We're going to learn today the Thevenin's theorem. So the Thevenin's theorem, I am just noting down those who already left the class. I'm going to collect the information about them. Actually, what is the reason? If it is reasonable reason, it's no problem. Otherwise, I need to know actually why you are not attending the class, it will affect your performance also if there is no reasonable reason, remember. Okay, now let's come back to the point. I'm not forcing you to come into the class if you have some problem, but if no reasonable problem, just amusing the life, that's not acceptable. Okay, now let's come back to the point. So everybody try to be in the class. Okay, before going to this, we're going to start the class. I would like to show you the, I would like to show you one thing that is, just 1 minute. Um, okay, can you, hello? Can you see the screen now?
Yes, sir.
Yes, sir.
Okay, all of
Yes,
you look at it. This is the cover page I'm talking about. You can download it from the BUX, and it is the midterm exam cover page. So what you have to do, you can download it today also, and you can get a printout of it and be ready with this, and also fill up this thing and be ready with this. And on Thursday, when you come for the final for the midterm exam, then you keep it in front of you. And all what you have to do, you have to write your name, ID number now after printing, ID number, course title, electrical circuit 1, course code EEE201, and semester summer 20 online, and section 1. That one you have to fill up by hand. And after that, you do the next part, that is your what do you call that? If you go the second part here, you have to sign here. I'm sorry, not here. This is what you have to write at the end of the exam. How many pages you are going to use? Let's say you are going to use four pages. Okay, then you have to write here 4. Remember, this thing you have to fill up on Thursday after the final after the midterm exam. You can confirm at that time how many pages you are using. Okay, this signature of the examiner and date, you don't touch here. Leave it empty. This is my place. I will sign and I will put the date. Okay, and you have to sign and date. This is very important. Have you gone through this thing? I think you all know about it, right? The honor code.
Yes, sir.
Okay, this honor code you have to sign manually here. You have to sign here and you put the date. Date will be the exam date on Thursday. So sign you can do, the date and the number of pages you have to do it on Thursday. If the exam is over and if the exam is happened, then how many pages you are using and what is the date of the exam. Let's say the exam is changed, not Thursday, it's on Friday, for example, then the date must change. That's why you don't write the date. Date should be on that day, but signature you can do it now. And the rest of the thing you can fill now. All these things you can fill now. So I am suggesting everybody to get the printout. After downloading, get the printout and fill the cover page, because it will be a big problem otherwise on the exam day. So I appreciate everybody to be ready in that way, so that no hassle during the exam day. I hope that everybody understood it. And if anybody had any problem, let me know. And emergency case, call me. I think that should be fine. Everybody okay with you? Hey, Dux.
Yes, sir.
Okay,
Yes,
good.
sir.
Now let's go with our normal class. And yep. Just a minute. Let me share. Yep. Okay.
Sir,
Yeah, go ahead now.
I have some problems in the practice problems for superposition, source transformation.
Okay, can we discuss this thing after the class? Because I have to finish the class and then you stay back and we'll discuss it, no problem. And anybody got, okay, I'm just asking you one thing. Who is the guy talking? What's your name? What's your name?
Sir, me, Sir Farhan.
Farhan. Farhan, is the first time you heard the name Tahmid from me, right?
No, sir.
Are you shy to go?
Sir, I went once.
Okay, and you found something wrong.
No, sir.
And then why don't you? Because that is, he's the ST. I appointed him as the ST unofficially because he was working as a ST last semester. That's why I told him. He agreed and he is serving. Why you are not?
Sir, I went there once and the
No, please, you can go anytime, any day. If he says anything, you tell me, sir, he said not to go. Then you can tell me. I can.
No, sir. He took like I know about like 2 classes and I went I joined one class and I couldn't the other one because like the current chilo na.
That's all right, but you told him.
No, sir.
You tell him he is so nice guy. He will tell you, give you another time personally. I know.
Okay, sir, I will.
Okay, if you're still having problem, call me. I'll make another appointment with you, and on that day, I'll give a consult. Anybody, if you have problem like that, after going through Tahmid is still not clear or still you are having problem, you please tell me and I will fix a special time for you and we'll discuss that time also. Okay, not in the class time. Class time I have to go for lecture. Okay, thank you very much. I hope that everybody understand so that no problem is unsolved. A to Z, everything should be solved by yourself, with your group mate, with Tahmid. Still cannot, then come back to me, I'll solve it. But no problem will be unsolved. Okay, just let me know by email or by, not email, you can just call me straight away at my mobile, or you can send me email also, or in the class. Just now you told me, so I'm asking you after the class, you stay back, we'll discuss it, no problem. But I appreciate everybody should go to Tahmid because that's the first step after discussing among yourself. Now let's come back to the point. Today we are going to talk about the Thevenin's theorem. Thevenin's theorem, I'm going to give you the idea. Actually, 2 things we are going to learn side by side. One is the Thevenin's theorem, another is Norton theorem. After finishing Thevenin's, then we'll start the Norton. 2 days actually we are going to require, and then next class we are going to see also Thevenin's theorem with dependent source. And if in the exam question paper, if you see in final exam question paper, most of the questions comes from Thevenin's dependent source. When you're going to solve Thevenin's dependent source problem, then your Thevenin's and Norton both you require together. So after learning Norton theorem, then we can solve the problem with dependent source, Thevenin problem with dependent source. Now today we are going to learn Thevenin's theorem in general. Now what is Thevenin's theorem actually required for? Now look at it. If you look at the circuit, any complex circuit, if you want to solve in a simplified way, that is what Mr. Thevenin's contribution. He solved the complex problem, tried to solve the complex problem in a simplified way. For example, what? For example, this is a complex circuit, for example, and this RL is the resistor. So you are going to change the RL, for example, for different time, you need to change the RL, and different time, you need to calculate what is the current through the RL. For different value of RL, different current is flowing, different voltage across RL, and different power absorption by the RL. So at different value of RL, you have to calculate every time with the different values. So Mr. Thevenin said, you don't need to go for do it all the circuit solution every time for different RL value. Rather, the whole circuit you can combine together like this. What he does, he said that you take it off this RL from here, you take it out, then the RL is coming over here. RL is going there like sort of way. So your RL, you take it out here. Okay, this is what the 2 terminal RL. That means he is going to cut it and take it off from here. So he said that after cutting it off, this is your two terminal, which is your A and B terminal, let's say. So the RL, this guy will be inside this A and B. Now he said take it off, and then you simplified the whole circuit in general like this. Whole dark, you can take it into, you see the whole contour, red contour. Under the red contour, whatever the circuit there, you can just simplify the whole circuit into one circuit, and that circuit, he said, can be converted into this, like a simple voltage source and a simple voltage source. I'm going to draw like a battery, that will be easier. So he said that just draw like a voltage source and a resistance with this. Full stop. This is what he said will be the cycle, will be the circuit. So your red AB will be this terminal, will be AB terminal. So he is saying this is the way we can go for that. And according to his name, this voltage source name is E Thevenin, and this resistance name is R Thevenin. And now the whole red circle, the whole circle, the complex circuit can be replaced by one battery and one resistance. The whole blue circuit under the red circle is converted into two element, only two element. What are they? One is the battery, one is the resistance in series with that. This is the way Mr. Thevenin used to solve his problem. The whole complex circuit is represented, and then what he did, he said now every time whatever the RL value, you can bring that RL over here, and your RL you bring it here, and you can now put your RL every time, different RL you put, and you can find your current and voltage and power. It is very easy. You don't need to solve the complex problem again and again for different RL. Got my point?
Yes, sir.
Okay, good. This is what Mr. Thevenin's idea, because it's very simple. Yeah, what is the current? It's just the current you can find easily. E Thevenin divided by R Thevenin plus RL. Whatever RL value you're changing, you can find the current. What is the voltage? That current into RL is the voltage. And what is the power? I square R. The I you already know. So this is the way you can now easily solve the problem for different RL value in this simple circuit. That's the big, that's the credit from Mr. Thevenin. He is a French scientist, and he had developed this thing in his time, theory. And according to his name, actually, this theorem is known as Thevenin's theorem. What is the theorem? Theorem is what is the way he convert this complex circuit into only two elements. One is voltage, one is resistance. This is what his main contribution. Now let us see first how he got these two elements. One is what? One is the R Thevenin, another one is the E Thevenin. These two things you have to find out from this complex circuit. That is the main job of Thevenin's theorem. So these two things, how you get. Now, in order to find R Thevenin equal to what? If you want to find first, then that is the first thing you have to do, remember. Your first job is to do R Thevenin, then you go for E Thevenin, not other way around. Then it will become easier. So how to find R Thevenin, that is a question. Look at it. That Mr. Thevenin, what he did, he looked through this channel, which is what? RAB. And RAB is nothing according to his name, R Thevenin. That is what is the value if you look through this point. If you look through this point, when you are going to find the R Thevenin, remember Mr. Thevenin said at that time, when you are finding R Thevenin, at that time, all, hey, what happened? Some of the ducks making sound. I'm muting that guy. And okay. Okay, no problem. I think then it's all right. Okay, now listen. Mr. Thevenin said that you have to deactivate at that time, deactivate deactivate all the independent sources. Independent sources. Remember, this is very important statement. Okay, this is what is the most important statement here. When you're going to find first R Thevenin, and according to Mr. Thevenin, it is said that all the sources should be deactivated. Okay, we have one source, which is what? Voltage source here in this circuit. So the voltage source, I'm talking about this guy. This is the voltage source in our circuit. This voltage source E should be deactivated. Can you remember how the voltage source is deactivated? How the current source deactivated?
Yes, sir.
How the voltage source deactivated?
So short circuit and current should open circuit.
Good. That's what we have started last time. So you have to short it here. So we are going to take it off when you're going to find R Thevenin, and we have to short it in this point. These 2 points should be shorted. I think you did it in the super node case. You have seen the 12-volt battery, how we deactivated. 12-volt battery, we deactivated by shorting it. Okay. And current source, 7 ampere current source, we deactivated by opening it. So you know that already. So this is how you deactivate. Once you deactivate, then you can now easily find what is the resistance from here. So now you can just go for series circuit, parallel circuit, or whatever way you can find the resistance from here. Now from this you can find the R equivalent equal to what? Straight away you apply the formula and then you can find the R Thevenin. So very straightforward, you can get it from here in this. All now you'll find the R equivalent, RAB in this way. Now there's no resistor, no voltage source, no current, so all are resistance. So this circuit you can easily solve for finding the RAB or R Thevenin. This is how you can find your R Thevenin from this circuit. Now to find the R Thevenin or RAB, maybe you need to apply some sort of a series parallel combination, delta Y combination. Delta Y combination you haven't studied yet. That one I'm going to teach you later. I'm talking about for today we can solve the problem easily. So this series parallel combination can give you the solution and you can find the answer for R Thevenin. You get 50% marks because R Thevenin you are finding means 50% of the task is done, because 2 things you have to do. One is R Thevenin, one is your E Thevenin. So you've done R Thevenin, now only left is E Thevenin. Okay, R Thevenin is done. Can you see? Okay. Okay, so E Thevenin you have to do now. If you go for E Thevenin, then next is what is the E Thevenin you have to find. So if you want to find E Thevenin, what is the way to find E Thevenin is our next job. To do it, it is the exactly the same circuit you have to consider, but not like that. It is, you have to consider the voltage source as it is, and then is the resistance here, here, here. Just I'm talking about, this is the thing here. Okay, so maybe there is another resistance here, for example, like that. So it is the RL AB thing was here. You, for finding the R Thevenin, actually this part was taken off, as I say, and RAB was there. A is here and B is here. These 2 points. Just you can imagine. If you go back, you can see the thing here like that. So the circuit is like that. Now, in order to find E Thevenin, or what is the target? Our target is to find the E Thevenin. E Thevenin, I'm talking about E Thevenin is this one. E Thevenin, which is known as EAB. EAB means this is plus and this is minus. This is plus and this is minus. EAB, the voltage in between A and B, that is your EAB. And that EAB is known as E Thevenin, which is also called open circuit voltage because the circuit is open, which is also known as E Thevenin. This is what the second next step, open circuit. First you find the RAB and then you find the voltage across AB. RAB gives you the R Thevenin and then you find the EAB, which your Thevenin voltage. Now how to find this Thevenin voltage from here? You already know the technique. It's very simple. You can find what? Mesh current method. If you go for the mesh current method, then you can easily find one, I1, I2, I3, and you already know how to do it. All of you tell me, will there be any mesh here or not? Hey,
Yes, sir. There will be.
there will be a mesh here or not?
No, sir. There will not be a mesh there.
Why not?
That's all. Sir, that's a open circuit and there is
Excellent. This is the main thing, because this circuit is open circuit, so there should not have any mesh. How come mesh current? Current this is open. Mesh current will not flow, right? So there will be no mesh here. Let's say if there is a resistance here, if there is a resistance here, yes, then you can say yes, sir. There will be another mesh current there, but the mesh resistance is taken off. So there should not have any mesh current in that loop. All of you understand?
Yes, sir.
Good. Any question? Please let me know. Anybody? Okay. Now, this is a concept of mesh current. I am not teaching you here mesh current. You already know the mesh current last class. So you should know that there should not have any mesh at that loop because there is no resistance. Circuit is open. Okay. Now let's come back to the point. This is very simple. This 3 mesh current, you can find the value of I1, I2, and I3, and then you can easily find your EAB, open circuit voltage. Open circuit voltage EAB will be what? EAB will be, let's say this is R1, this is R2, for example. This is R1 and this is R2, and this is R3. So what will be the EAB? EAB will be, if EAB will be from here, if you come from here, then EA will be the voltage across this, the voltage across this, the voltage across this. So this is the EAB, plus minus, plus minus, plus minus. This is the EAB voltage. Or if you apply the KVL, then you can see the KVL gives you EAB equal to that. So what will be the voltage? Voltage EAB will be ER3 plus ER1 plus ER2. So ER3 will be what? Anybody can tell me what is the voltage ER3, the voltage across R3? This is just a conceptual thing I need to ask. I need to know. Anybody can tell me what is the ER3? What is the voltage across R3? Anyone?
Sir, I didn't understand clearly this part actually.
Oh, I'm telling you, this is EAB equal to, I'm talking about EAB will be what? From A to B, open circuit voltage will be the summation of all these 3 voltages, right?
Yes, sir.
That was I have written here. Now I am writing the voltage, each of them. What will be the voltage here? What will be the voltage here? What will be the voltage here? That's what I'm talking. For example, if I ask, what is the voltage ER1? ER1 voltage is I1 times R1, isn't it? Do you understand it?
Yes, sir.
And if I say, what is ER2? What will you tell me? Tell me.
R1 into R2.
You duck. R2 into R1 into
I3,
R2.
sir. R2 into I3.
Right. What are you telling me? R1 into R2. I3 into R2. This is, do you understand it?
Yes, sir.
So what are you saying? R1 into R2? Hey, rest of you, please open your mouth if you have any question. Okay, ER2 is that. ER1 is this. These 2 voltages you understand, right?
Yes, sir.
We don't need any other voltage. Only another voltage we need is R3. What is ER3? Now can you tell me what is ER3? That is, what is the voltage across R3? Anybody? This is a very much important question among the EEE students, especially EEE 201. You have to understand it. The open circuit voltage, to find it, these 3 voltages you are going to add, but everything, you know, I1, I2, I3. From the loop mesh current method, you already got the value of I1, I2, I3. Assume this thing you already found because you know the mesh current method, right? This thing you know. Now you substitute this I1 and I3 here and you get these 2 voltages. What is R3? ER3. ER3 should be added there. ER3. Anybody can tell me? Nobody? Okay.
Sir, is it 0 volt?
Absolutely. Why you said 0?
Because there is no current is passing.
Absolutely great. There is no current flow. It is open circuit. Are there any current flow through R3? If you, anyone among in the classroom do not understand it, you better drop EEE department, because A and B is open. A and B is open. This part is open. No current will flow through R3. This part you all need to understand, that I equal to 0 here. If the circuit is open, should not flow any current through R3. If you cannot understand it, you are worse than a child who is in the stray, who is moving around here and there and no idea about anything. And if you are EEE201 student, everybody must understand it, that there is no current flow through R3 because it is open circuit. Understand it now, all of you?
Yes, sir.
So I am going to, this is very important and conceptual thing. In future, you need it. So we are going to get 0 is the current. This is R3. You can write like this. So it is gone. So your voltage is coming here like this, R3, R2. This is one way you can find your EAB, and that is your E Thevenin. This is your E Thevenin. EAB, that's whatever the way I1 and I2 value you got from here, that one is substitute, and R1 and R3 value is, R1 and R2 is already given. So you substitute that and you can get some value, which is your E Thevenin. This is how the E Thevenin we can determine. Once you get the R Thevenin and E Thevenin, then Mr. Thevenin said we have our simple circuit like this, which is having the E Thevenin and R Thevenin. Now, everybody understood this thing?
Yes, sir.
Okay, now I am telling you, I know some of you are still having question about this equation. Yes or no?
Yes, sir.
Okay, I want to see only one person is saying yes, sir, and rest of them are watching movie.
No, sir, we have also questions.
So why don't you ask me then? I'm asking you that question. You should ask, because this is the fundamental thing we are learning. And next time, I am just applying the Thevenin's theorem to solve another problem. At that time, this basic thing, you will not understand. You'll be in trouble. Now listen, you should not have this question, because if I ask you, write the, all of you look at it. If I ask you, write the KVL here. KVL here in this loop. How many voltages in this loop? There are 4 voltages.
So 3 and the 3 voltage.
3 voltages, another voltage EAB. EAB is another voltage here. EAB, right? We are going to think that from A to B, there is another voltage. So there are 4 voltages. If you say 4 voltages and start from this node, let's say start from this node. I can go like this, come back to this node. Like this way, if we go to complete our loop like that, if we can see for KVL. So if you go, start from here, then voltage, what is that? I1 R1. I1 R1 is a voltage rise or voltage drop?
Voltage drop.
I'm talking about ER1. I1 R1 means ER1.
Okay.
ER1. So ER1 is this voltage. The ER1 is voltage rise or voltage drop? Anyone else?
Voltage rise, sir.
Voltage rise. So voltage rise is positive or negative? We assume?
Positive, sir.
Positive. So let's say positive. Now, if you go to ER3 here, and this is plus minus if you consider, then what is this? It's also voltage rise. So it is ER3 we are writing. ER3. Now, AB, VAB, EAB, plus and minus. This is plus and this is minus. So EAB will be what? Voltage rise or voltage drop?
Drop, sir.
Voltage drop.
Voltage drop. So I'm going to go for voltage drop. Voltage drop means what is negative or positive?
Negative.
So EAB is negative. Then you go for this one, ER2. So ER2 will be what? Negative or positive? Voltage drop or voltage rise? The current is, this is plus and minus, right? Current I3.
Positive.
Voltage positive because it's voltage rise. So you are going to go for ER2. and this is equal to 0, right?
Yeah. Okay.
Now, can you get it back, this thing? Yes or no?
Yes, sir.
Yes, sir.
So this is what, if you cannot understand that way, then you should understand this way. Applying the KVL also give you this same thing. But how I have done, I'm just going to show you in a separate one, then you can get it. I'm going to show you here. I have done like this. Ting tong ting, whatever it is, like this, and it's not important. It is open. It is open. Okay, I'm just going to show you here. Okay, I said that this is plus and minus AB, EAB, open circuit voltage we are going to find. So this is plus minus. So this current is flowing this way. There's a plus and minus. Okay, ER1, maybe this one. This current is going like that. This is ER2, ER2. This is plus and minus because follows the associate law. And this is no current is flowing through that. So you can, whatever, you can go for it. If you say from here to here, if you come this way and this way, so this is, let's say, plus and minus, you go for this. This voltage is meaningless, no voltage there. So no current flow. So you can arbitrarily consider plus minus, no problem. So because this part will be vanish anyway. So if you go from here, then what is this? This one, if you say VAB, VAB will be what? This voltage plus this voltage plus this voltage. So plus minus plus minus plus minus. So you are just going to write ER3 plus ER3 plus ER2 plus ER1 plus ER2. ER2. Now, if I see the current is in opposite direction and this is negative and this is plus, then definitely we should write here a minus sign there, right? That's what I'm talking from this open loop voltage. This is the summation of this plus this plus this. This voltage equal to. That's what I'm talking about. Or if you do not understand this way, then you can just follow. This is EAB, and this is plus minus. So I'm just copying the loop, and the loop can give you the KVL, and from the KVL I can write the full equation, and that equation ultimately giving me this thing. I think that whatever way you understand, either in the KVL and KVL gives you this, should be fine, no problem. All you understand is that E Thevenin means the open circuit voltage, and this is the way to find the open circuit voltage. And now you can ask me a question.
Sir, can any resistance rise voltage when a current passes through resistance?
Which is R1, R2, R3?
Any kind of.
Oh, yeah. Go ahead.
Not in this circuit, but any other circuit. Can resistance somehow raise the voltage?
Current can flow in the different way.
Yes, sir.
Yeah, that's what I'm just telling you. If it is, it can. Yeah, it can. We'll solve some problem. Then you can see that one. But not using the mesh current. If you find the mesh current method, then I1 will be negative in that case, the result. I1, this current gives you the negative value in that case. So if this gives you the negative value, this got, then it will be opposite thing. It is coming in that way. We'll solve the problem now. If we solve the problem, then it will be very, very clear to you. Now we are going to do that. Then it will be much, much clear. Let's come back to the point. This is a complex problem I have taken from the example. Actually, the problem will not be complex. It will be from the, okay, I'm sorry. It will be simple. So I think this is the slide we are going to talk today. Thevenin's theorem, as you all got the slide, I have already uploaded in the BUX. Okay, so let's go with the next thing here. Look at this. This is what the first page for this one, and it is told that Thevenin's is from a France. He's a French scientist, and he had developed this Thevenin's theorem. According to the definition, is tells that any two-terminal linear bilateral DC network can be replaced by an equivalent circuit which is consisting a voltage source and a series resistance. This is what I was talking about. Linear bilateral DC network is a clean resistive circuit, because resistance is Linear, as I told you, this is a linear, but a capacitor, inductor, those are non-linear. We'll show that later, but linear resistance linear, you know that, because V equal to IR, Y equal to MX at the beginning, first class I told you already. So this linear should be bilateral. Bilateral is a both way the current can flow. It does not make any sense. So difference. So the current can flow in both way, from left to right, right to left. So that's now any two-terminal network consisting of resistance, you can imagine like that. That can be replaced by a single battery voltage source, means battery, single voltage source, and a resistance with series, a single voltage source and a resistance with series. That voltage source is your E Thevenin, and that resistor is your R Thevenin. That is what actually Mr. So a two-terminal network can be replaced. Where is the two-terminal network? This is what two-terminal network is. This one I have told you at the beginning. This is a voltage source I told you, or some sort of things, and then this is A and B, the two-terminal network, and this is the two-terminal network, can be replaced by this thing. By replaced by what? By a single voltage source and a resistor in series. That is what the Thevenin's theorem. The two-terminal network is AB is the two-terminal. The two-terminal network can be replaced by a single voltage source, and this is the voltage source. This is the Thevenin. So this is standard Thevenin equivalent circuit, and this is your A and B terminal, where the RL I have taken out. At the RL you can take it back. It's okay now. You understand now the Thevenin's theorem from here and the example I have given you. Is it clear to you all?
Yes, sir.
Now we are going to solve a problem. If we solve a problem, then it will become much more clear to you. Now let's go for finding the solution of Thevenin's theorem. Now first thing, we are going to solve a very, very simple problem. Simpler than this, you never can get a problem in your life. Okay, first problem, we are example. This is example 1. If you look at it, this is the circuit, and we have a two-terminal network, A and B open. We have to find, you see the block, this is the box. The box means this is the red contour. This is the red circle. Red circle, hey, look at it. Can you remember red circle? Here, I told you the red circle. This is the red circle. This is the red circle box, like that. So in the problem is like, so we have to find what? From here we found this thing. We found this thing. That means Thevenin's voltage source and Thevenin's resistance from this box for the red contour. So here the same thing. From the red contour, we have to find this thing, which is, this is the E Thevenin and this is the R Thevenin. So R Thevenin and E Thevenin we have to find. So this is what actually done here. So how to do, that's a question. Now if you want to find the V Thevenin and R Thevenin, as I told you, first job, you have to do what? You have to A and B terminal through this, you have to find the R Thevenin first. I told you last time, first job is R Thevenin. If you want to find the R Thevenin, you look through AB, you find the RAB. If you go for RAB here in this way, what to do? All the sources, remember, all the sources should be deactivated. Remember, I told you, all the sources should be deactivated when you find the R Thevenin. Now, if you find the R Thevenin here, RAB, then all the sources, how many sources are there in the red box?
2 sources, sir.
2 sources, 2 voltage source, and you have to, how to deactivate, short or open?
Short.
Yes, sir. Good. So you have to short them. If you short them, now if I ask you what is RAB equal to, that means the resistance, if you look through this, yes, any children didn't born yet, he also can give this answer, that 6 plus 4 equal to 10. These two resistances are in series, and R Thevenin is 10 ohm, and this is 10 ohm. That's why it is written 10 ohm. It's very simple. This is the way you have to do your first job, R Thevenin. So simple. Earlier example, I have given you complex circuit. You have to go for, you know, series parallel combination, delta Y transformation. That's a complicated case. When you find the final exam, that time maybe you have to solve those. Now for understanding purpose, everybody understood it's a 10. So it is done. 10. RThevenin we have found 10. Now let's go for our next step, VThevenin. Now in order to find VThevenin, what to do? So you can see the RThevenin is found 10. Now VThevenin equal to what? If you want to find, then we go back to the circuit again. Now in this case you cannot deactivate, rather in case you have to activate it. If you keep this circuit active, then again what to do? This is A, this is B, so you have to find EAB, and EAB is nothing but your E-Thevenin. So what is EAB or what is E-Thevenin? You have to find it. Now if you want to find EAB, again this from here, if you look, this voltage plus this voltage plus this voltage plus this voltage, this 4 voltage will be summed together, gives you the EAB, right?
Yes.
Now what is EAB, right? EAB equal to, the first thing is this, the voltage 4 ohm, which is what? 0, because it's open circuit, right?
Yes, sir.
So no current is flowing through that. So the voltage across 4 ohm is 0. Then come plus the battery. This is a plus sign and this is the minus sign. So it is, what is the battery? 12 volt. So you should write 12 volt battery here. 12
Sir,
volt
isn't
battery.
it voltage drop?
Oh no, I'm not writing the KVL. If you write a KVL, then you can see that this is plus. Okay, then if you write a KVL in that case, I'm just going to show you in general sense. Is it the KVL I'm writing?
No, sir.
Here, I'm just writing this. The total voltage is, when you look into this, you are seeing that two resistors are, these two resistances are there. And in fact, there is no voltage across them because no current is flowing through the resistance, both resistance. So the voltage across this resistance is 0 volt. Voltage across this is 0 volt also, right?
Yes, sir.
Sir,
Okay.
isn't there two source
No,
making
listen, there are 1,000 sources connected, no problem. Since the circuit is open, there will be no current flow. It is true or not?
Yes, sir.
If there is no current, what is the voltage across resistance?
So 0.
No question after that. Shut your mouth. Then you come to the battery. Yes, the two batteries are there. Only those two batteries, these two batteries are connected in series. So what will be the terminal voltage from here to here? If you connect a voltmeter, what you get? You get the summation of these two battery, right?
Yes, sir.
And what is that? 12 and 4. But 12 and 4 are connected in opposite direction, right?
Yes, sir. Polarity are different.
Opposite different. So 12 minus 4 or 12 plus 4, what?
So 12 minus 4 or 12 plus minus 4.
Okay, 12 minus 4 or 4 minus 12, like that way you can tell. They are subtract from each other because two batteries are connected in opposite part. So you should write as 12 minus 4, that is 8 volt you are getting. Now, common sense say that's from here, the two batteries are 12 minus 4, that means your 8 volt. Anybody, if I ask, now look at it. If I ask here, a battery is connected here, another battery is connected here, and it is here. Just look at it. If I ask you, if you connect a voltmeter here, the voltmeter, this is a voltmeter, imagine, I think you saw the voltmeter. So voltmeter reading will be what? If this is a 5 volt battery, and this is a 3 volt battery, then what is the voltmeter reading?
2.
Yeah, how you find 5 minus 3? Exactly the same thing here. 12 minus 4, you are getting here 8 volt. Over here, I'm talking about this guy. Just think like that, because this resistance drop is 0. There is no resistance, are all dead. No current flow means all the resistance are dead. So you are getting what? Only this, like this. If it is okay, you said this is 12. Then if it is 12 volt, let's say this is instead of 5. If you write 12, then it will be what? 12 volt, and this will be instead of 3, you can write here 4. Then what will be this got? Same thing, right? 4 volt. So what will be the 8 volt here? Exactly same thing. Only the two resistances are connected here. You connect or not doesn't matter because no current flows, so no voltage. So only these two batteries are coming at the output terminal AB. That's why it is 8 AB. Okay, this is the way common sense is saying that thing. You can easily, you can straight away write it. Okay, if you say, look at it, some of you are confused. If you said this is negative, this is positive, then it is minus 8 volt, remember. Then it will be other way around, you have to go. That 4 minus 12, because positive terminal is here, negative terminal is there. So you have to go this way. So if you go this way, and this is 4, and this is minus 12. So the value will be minus 8 volt. You understand it?
Yes, sir.
Yes, sir.
Okay, that's the straightforward. Now, if you say, sir, we want to go through the KVL, then we have to apply the KVL. We have to find from the KVL. You can do that also, and you can also get the answer, and same answer you get. Remember, I'm going to do that, and you can understand it. This is plus and minus. This is EAB. I'm writing here. Now, EAB here. So, oh, is it clear? Can you see? This is EAB. Okay, I'm writing here EAB. I know that some of you will be annoyed, but for everybody's understanding. Okay, now this is, let's say 4E4. This is E4. This is E12. I think you can understand it. So if you go with this KVL here, with this loop, in this loop, if you go in this loop, the KVL, how many voltages are there altogether, along with EAB?
5 volts.
5 volt, good. So you can say that this is plus, minus, minus, this is plus, minus, plus, minus, right? And other 2 voltages, whatever you consider doesn't matter, because this is 0 volt, this is 0 volt. So if you write the equation, let's say from here, this is just assume any direction you can consider plus and minus. This one you can write also plus and minus, doesn't matter, because 0 volt. So this 0 volt, if you can go start from here, voltage rise 0. 0. Now you will ask me, sir, 0 will be plus or minus. Is it a big issue?
No, sir.
Okay, if you think it's a big issue, it should be positive, because we assume this is negative. So this is positive 0, positive 0. Okay, no problem. And then you are getting E1 voltage rise, which is positive 12 volt, positive 12 volt. I'm sorry, positive 12 volt, voltage rise, positive 12 volt. Then 0, that's a negative 0, voltage drop. Then EAB is voltage drop. So it is positive EAB. I'm sorry, negative, right? Voltage negative EAB. Okay, this is negative EAB. Then what will be the next one? 12, 4 volt. Is it negative or positive? What do you think? Can you tell me this 4 volt?
Negative, sir.
Negative, voltage drop. Good. This is what our understanding. And that's finish is 0. I know all of you are becoming a duck. Why? Because of this 0. Is it because of this thing? You all are confused, is it? Hey, is it because of this you are confused, is it?
No, sir.
Okay, good. Because this 0 volt, either voltage rise, voltage drop, doesn't matter. 0 is 0. I'm writing here. So, or if you don't understand, you can write like this. Instead of this, you can write E4 ohm. You can write here E6 ohm, because there are genius students, all are 6 ohm. After that, you replace E6 ohm equal to 0, E4 ohm equal to 0. Same thing. Now, if you go for it, now this is KVL. Now this KVL gives you EAB equal to what? Can you tell me? Still your brain dumb. You cannot do this calculation. EAB equal to
8,
what?
sir.
8. So this is what? 8 volt. That's what we got, 8 volt, using the KVL also. I think I told you KVL because some of you may be confused about it. That's why. But now if you apply KVL also, you see you are getting 8 volt here. So that's what I'm talking, that 8 volt is coming even if you use the KVL. So you understand it, that this is the way to find the equivalent, I mean Thevenin equivalent voltage and Thevenin equivalent resistance, you get your Thevenin equivalent circuit for this complex circuit. This is not complex at all. Now we can go for example 2. This is slowly we are going into the real problem. Now if you go for this second problem, I hope that now you can understand it. Look, shaded area, we are going to find what? This is the circuit given. We have to find, this is the contour, the red contour, and we are cutting this. Mr. Thevenin did what? Cut this RL, the RL is taken off. And then what he said, he had found the equivalent Thevenin circuit, which is this one. So what? This big red circuit will be replaced by two elements. One is the Thevenin resistance, Thevenin voltage, and Thevenin resistance. That's all. And then you put it back. The RL, you put it back here through the AB terminal. This is the AB terminal. AB terminal. Now I hope that you understand the first example like that. RL, you take out the RL. It is a AB network, two-port network, and then the whole red circuit is converted into the blue circuit, which is having only two elements, R Thevenin and E Thevenin. Now, how to find these two value? First thing, you have to do what? You have to find the value of R Thevenin. So that's your first job, and then you go for E Thevenin. You understand the problem?
Yes, sir.
Good. Now, for your understanding, I am going to put the value of the resistance and the voltage source as a constant, some sort of value I am giving you. Let's say the voltage, battery voltage, I am giving you 5 volt. The resistance R1, you can assume it is 1 ohm. R2 is 2 ohm. And R3 is 3 ohm. I'm just giving you the example. All of you can get a snapshot of these things so that you can understand it. Okay. Assume this R1 as a 1 ohm, 2 ohm, and this is 3 ohm. If this is the scenario, then our first job is to find R Thevenin. If you want to find R Thevenin, I told you R Thevenin means your first job. R Thevenin means you look through this into this RAB. Through the A and B network, you are going to find the RAB. What is the RAB? If you look through the window, through the AB window, you find the equivalent resistance. But one thing you have to do, what is that? Regarding the source. Anybody?
Yes, sir. I have to short it.
Because you have to deactivate the source. And there is a voltage source. You have to deactivate the voltage source. That means you have to short it. Hey, all of you understand, or your brain short circuited?
No, sir.
Okay, good. If you understand, if it is short, if you short it, that means what? This 5 volt is become 0 volt. No more 5 volt. It is a short circuit. It's a short line. This line is shorted. If this line is shorted, okay, this line is shorted. Now RAB we have to find. What will be the value of RAB? Anybody can tell me now. This RAB I'm writing here. RAB will be equal to what? Can you tell me, anyone? If that is shorted.
1.5 volt.
1.5 volt. How you got 1.5 volt?
So 3 and 2 are parallel.
Excellent. So rest of you try to understand what he said. He said that if this 1 ohm is shorted by this short circuit, the 1 ohm. If 1 ohm is shorted by this line, then this resistance will become redundant, isn't it? No current will flow through that because the resistance is short circuited. Hey, you understand?
Yes, sir.
Hey, rest of you, anybody got question? All of you understand it? Go.
Yes, sir, I understand that, but I didn't understand how 2 and 3 come to parallel.
No, we are coming to that one, but up to this you understand or not? That is R1 is redundant. You know, redundant is used as dead because there is no current flow through R. It is shorted. R1 is 1 ohm resistor is shorted. That means no current will flow through the R1. Means R1 is redundant, is dead. No current, no blood flow. That one you understand. I'll show you later 2 and 3, how it's parallel. But this thing you understand
Yes,
or
sir.
not? Yeah, that one
Yes,
I'm
sir.
asking you the question you should answer. You're jumping to the sky. Now, if this is parallel, now I am going to draw this circuit in the next page so that you can understand it. Now you see you can get it or not. Okay, the resistance one here and another one here. This is 2 ohm and this is 3 ohm. And as I told you, this is 1 ohm. This one was 1 ohm resistor. Just look at it, and it was shorted because the battery was here. The battery is short circuited, so it is shorted. That's it. Now this is the circuit supposed to be, and I said this is the 1 ohm is shorted means this is redundant. You understood it. Means I am taking it off from here, so the circuit is like this. Got it now? Hey.
Yes, sir.
Okay.
Yes, sir.
Now this 2 ohm resistor, you're bending down, and you can bend it. Can be written to like this. Can it be written 2 can be brought like this? I can take it off. Can do that.
Yes, sir.
Yes, sir.
So what happened? 2 and 3?
Yes,
Parallel.
sir. Parallel.
That's what your friend said. 2 and 3 is parallel. So RAB is means 2 and 3 is parallel. What is that? 1.5. Is it?
1.2.
Hey, 1.5. Who told me? Kill you.
So nobody told me 1.5. 1.2.
What is it? 1.2 you told me. Okay. Anyway, now let's come back to the point. 2 and 3 is in parallel, which gives you 1.2 ohm. So your R Thevenin here is 1.2 ohm and the answer. So 50% is done. Next, what is the next 50%? Next 50% is E Thevenin. Now let's go with the E Thevenin part. Now, if you want to go for E Thevenin, you have to come back to the original circuit, which is like this. So in your original circuit, if you go there, now you take it off, the resistance part is gone. Resistance part is not necessary, it's what it found. Now, if you want to find the E Thevenin, then again, this is a E and A. This is A and B terminal. That is means this is plus and this is negative, and this is your EAB. I'm writing here. This resistance is EAB. RL is taken off. Now EAB here, from here to here is your EAB. That is what your E Thevenin you have to find. Now, if you want to find E Thevenin or EAB, now you look. EAB means what? This is your point A and this is your point B, right? EAB means the voltage across what?
3 ohm resistor.
Across 3 ohm resistor. This means this green line is coming up to this node is up to this. So EAB means this is EAB also, right? All of you understand it?
Yes, sir.
Up to this. Okay. So what is the EAB? EAB means across the 3 ohm. You are right. EAB means the voltage across 3 ohm resistor. 3 ohm resistors means the current flow through I3 ohm into 3 ohm resistor. Ohm's law. The current flow through the 3 ohm and into, isn't it 3 into I?
Yes, sir.
I'm talking about the current I here. Let's say I, not 3 ohm, I. So I think you can understand better. This is what? I into 3. Every children should understand it. If the current I and 3 is the resistance, what is the voltage? 3 into I, right?
Yes, sir.
Yes, sir.
So this is what EAB should be. The voltage across the 3 ohm resistor will be the EAB. Now, all your job is to find the value of I from the circuit. Now, what is the value of I? This is the question. Anybody can tell me now.
Sir, 1.
How you find, okay, what is the voltage source value I assume? Can you tell me, anybody? I told you to get a snapshot. What is the voltage?
5, sir, 5.
Good. If you assume this is 5 volt. Now,
Sir.
Yes, sir, go.
Sir, we can, without finding I, we can also do it by voltage division.
Voltage division rule also can do.
Yes, sir.
Exactly.
And that's why I said a result will be 3, sir.
3. Okay,
According
your
to
voltage division rule said EAB equal to what? Can tell me.
Yes, sir. EAB equal to
Tell
3,
me
sir.
formula.
3.
Same thing, but go ahead.
Sir,
EAB equal to, yeah.
I have a class now.
Oh, it's time's up. Okay. Yeah, those who have a class, you can go. I'll just continue and I upload the video. If you have a class, you can just leave and you can see the video. Okay. Thank you very much. EAB equal to voltage division rule. Can you tell me?
Yes, sir. So
5 divided by?
5
How you
divided by
found?
2 plus 3.
2 plus 3 into
3.
into 3. Excellent. This is giving you the value through the voltage division rule, which is giving you what?
3, sir.
3. So you are getting the E Thevenin equal to 3 volt. I don't need to go that explanation then. Okay. Also, you can go for this one as well. I is the current flow, and that I is going through. So I will be equal to what? I will be equal to, from here to here, it is voltage 5 volt plus minus 5 volt. So 5 volt voltage division rule actually. I equal to 5 divided by 2 plus 3. This is the current 5, which is 1 ampere. So 1 ampere current, and this one you are just going to 1 into 3 is a 3 volt. So you are getting the 3 volt as well. So ultimately your current, what do you call that? Thevenin's equivalent is like this. This is the Thevenin voltage. This is the Thevenin resistance. Is the answer is here AB. So you should write here 1.2 ohm R Thevenin, and this is your E Thevenin, which is plus minus 3 volt. So this is the full marks you get the Thevenin's equivalent circuit after finding this. You can get the full marks. Now let's come back to the next problem. Just we are going to, those who are having class, you can just leave. I'm going to finish it faster. Now, this is the similar type of problem and very easily understood, all of you, that it is said that the rate, you have to find the, if you read the question, Thevenin equivalent, you have to find for network A. Network A is this one. This is the rate control line. You can just see this thing, rate control line. So you have to find the equivalent for this. The equivalent, if you want to find, you have to find a Thevenin equivalent. This is the point A and B. You can just imagine A and B. So this is the thing you have to find, A and B. Please stop, A and B. So they're asking about to find your R Thevenin and E Thevenin equal to what? It is plus minus. That means from here you have to find the Thevenin. Forget about these things, the RL. You have to take it out and then bring it back. So question is what? What is your R Thevenin? What is your E Thevenin? And everybody can easily find what is the value of R Thevenin. If you take it off and look through this and find the RAB equal to what? If you want to find RAB, the voltage source should be shorted because deactivate. And then what will be the resistance RAB? Can you tell me?
Yes, sir. 7 and 6 is series, and then it was parallel with 3 ohm, and answer is 1.5.
Answer is 1.5. Any other answer? Is it correct? All of you agree?
Sir, 1.5, I said.
Sorry,
Sir, it will be 9 ohms.
I said 9 ohm. Any other? Okay. How you got 9 ohm?
Sir, here 3 and 6 ohm are in parallel, which gives us
okay, parallel
2 ohm resistor, and 2 ohm resistor will be in series with 7 ohm resistor.
Excellent.
So in total we get 9 ohm.
Right. This is the way. Now you can see this is the way to go. And so 7 plus 2 is giving you 9 ohm. So your R Thevenin is going to be 9 ohm. Everybody understood? Please response.
Yes, sir.
If anybody
Yes,
got question, I'll explain it in details. No, then I can jump. Okay, now that is done. Now we go for R Thevenin or E Thevenin. You know, find E Thevenin. Then we can just jump back to the problems here. R Thevenin. Now we're going for, okay, just coming back. I think we can take it off. R Thevenin is done. So I don't need to, I'm going to take it off. Now let's go for E Thevenin. And if you want to find E Thevenin, the voltage source should be there. And E Thevenin means you have to look at the RAB. AB is here, A and B. And look through, this is the positive terminal. This is the negative terminal, AB. So you are going to find EAB here. EAB, if you want to find EAB will the voltage drop across 7 ohm and 6 ohm, right?
Yes, sir.
Plus minus, plus minus. So if EAB you write, so voltage is 7 ohm plus E6 ohm. So E7 ohm is 0 because it is open circuit, right? There's no current flow. Got it? Because this is taken off RL. You understand it?
Yes, sir.
Yeah, only the voltage across 6 ohm resistor. Then what is the 6 ohm resistor? It's very simple. What is that? It's a current into this. What is that? 6 ohm resistor, the voltage.
6i.
Okay, 6i. It's a very simple job. 6i. Now question is I equal to what? Okay, good. I think it's an excellent way you told me. And this will be what? 12 divided by 3 plus 6. Right? Now, what is the
Yes,
answer?
So 1.33.
1.33. Is it correct? No? Hey, come on.
So this is the current value, sir.
I'm talking about total value.
Sir,
I'm talking
8
about
volt.
this thing. This is 3, huh?
Volt, sir.
What is that?
8, sir.
8
8,
volt.
sir.
That's good. It makes sense. 8 volt. So you are getting 8 volt. If you can, but do you understand it? The 6, you told me 6 into I. I put the I. Now you multiply with 6. Are you getting 8? Yes.
Yes, sir.
Yes, sir.
So you are getting 8 volt here. So your E Thevenin is 8 volt and R Thevenin is 9 ohm. As a full marks you get. That's done. So simple. Now next problem, we can just finish it faster. Next one, we can go with this one. If you go with this problem as a solution to this problem, then it's the same thing you have to do. With A and B, you can just cut it off and you have to go for what? You have to go for a Thevenin equivalent. You have to find it. A and B, you just take it A and B, R Thevenin here and E Thevenin here. Now you can slowly you can see it will be some easier. Now R Thevenin you have to find, you can just cut it off and then look through this. You get the RAB. RAB will be what? This is a current source. What to do?
So open.
Open. Deactivate means you open the current source. If you open the current source, what will be RAB?
6 ohm.
6 ohm, because these two resistance coming into series, 2 plus 4. The circuit is less like this. You understand it? The circuit is just like this. This and this. This is 2 ohm. This is 4 ohm. Because the current source is taken off, isn't it? Current source is taken off. So the resistance RAB will be what? The summation of these two resistance, 2 plus 4. 2 plus 4 is 6 ohm. So you're getting 6 ohm. So R Thevenin is 6 ohm. All of you understand?
Yes, sir. Sir, so in case of the voltage, we short circuited, and in case of current source, we open circuited.
Right. According to that, you understand it or not?
Yes, sir.
Good. Now let's come back to the next point. The next is E Thevenin. We have to find the Thevenin voltage. Now to find Thevenin voltage, you cannot deactivate it. You have to keep it active. Now, this E Thevenin is, you have to carry it off, and this is your plus, and this is your minus. That means this is your plus, this is your B is a minus. So EAB, you have to find EAB equal to what? So if you want to find EAB from here, it is taken off, remember. The EAB is what? If you go, you can just look through this, and AB will be this voltage plus this voltage, plus minus. Then you can say E2 ohm plus E4 ohm. Hey, E2 ohm is what? Because you okay, can you hear me?
Yes, sir.
I'm sorry. Okay.
Yes, sir.
Now look, this is 0, right? You understand it because there's no current flow. 0, it is open means no current flow. So 0, 0 volt, and 4 means, again, 4 means what? E4 means E4 ohm. Anybody can tell me that I into 4 is a current is flow through. This is I. So 4 into I into 4, or 4 into I. Right. So what is I? I is this current. This current is flowing. and the component going through this is 0 ampere, and all the current going through. So I will be what?
So 12 ampere.
Excellent, because 12 and this is 12 ampere. If 0, because it is open, so no current flow, all the current will go through this. So I will be, all the 12 ampere will go through this. So I will be 12 into 4. What is that?
48.
48 volt.
So you're getting 48 volt. So your, this is 48 volt. So your EAB is 48 volt. So your Thevenin is 48 volt. Do you get it now?
Yes, sir.
Good. Hey, anybody got question here? I'm jumping to the next problem. No. Good. Now you see this problem. Okay, this is a little bit a different type of problem. Okay, just before that, I'd like to clear it again and bring it again, because I need to put in the right place. Okay, here. I think it's all right. Now you look at it. This is a little bit different way, the problem. You can just, if you read it, first thing you have to find the Thevenin's equivalent circuit. Then you can see first that you have to find the Thevenin equivalent first from this blue contour, exactly this AB network. Now you're very much confident about these things, because today's class you understood much more better. So this is the plus and this is a minus sign. So all what you have to do is you have to go for a Thevenin's equivalent circuit. You have to develop, and you already know how to do it. And it's a straightforward AB, and this is R Thevenin, and this is V Thevenin or E Thevenin, whatever you say. So this is plus minus E Thevenin. Now R Thevenin, actually for this sort of case, you have to find the R Thevenin first. And last class we have seen the R Thevenin was RAB, as you remember. RAB we can find from here. When you are going to find the RAB here, then you have to short the voltage source, deactivate the voltage source, and these things we have seen already. RAB will be in that case 15 ohm resistor, and this these two will be connected in series, and that will be in parallel with that. So you are going to get the 25. You're going to write here 25 parallel with 15 plus 10. That gives you 25 parallel 25 is a 20.5 ohm. So this part, I think you understand that 12.5 ohm resistor is the value of R Thevenin. So this is done 50%. Now, second part is VAB we have to find. After that, this is all what we are doing for part A. This is what I'm talking about. Part A we are going to solve first. That is the Thevenin equivalent we are finding. So 50% done, another 50% is coming from the rest of the part. That is, we are going to find now the E Thevenin. You have to find E Thevenin, as we saw last class, that E Thevenin should be found from here in this way, that is open circuit voltage. The E Thevenin is what? E Thevenin is EAB. EAB is the open circuit voltage. That is your E Thevenin. So EAB, A will be here and B will be here. B and A, this two terminal. So what will be the EAB voltage if you want to find? EAB voltage, as you see, this is the node and this is the node. It means from here to here, this point to this point. You can say this is also A point and this is B point. This is also B point. So A, B point are these 2 points actually, you can say also. Now, from here to here, VAB, if you want to find, that means this source and this source, these two voltages are going to be added. That's it. So if you consider the current is flowing in this direction, assume the current is coming in like this, sorry. Okay, current is coming like this. Okay, if you assume like this, then the current is going like this, then kind of this, and this. This is the way the current flow through the circuit. Assume like this. This is a closed loop path because this is open, so this part is closed loop. So circuit, and the current flowing through this, let's say this is I current is flowing, for example. If the current is I current, we can assume then what will be the EAB voltage from here to here? EAB will be 100 volt, because 100 plus minus, so 100 volt plus, this is what, plus and minus 25I, right? 25 into I. 25I is the voltage drop here. So you can say this is 25I. This is what the voltage you have to know. Yeah. Now it is what? It is 100 plus 25, and I is the question now. What is the value of I? Now, if you can find the value of I, you can get the Thevenin. Very simple. Now, in order to find I, what you have to do in this loop, you have to go for what? Can you tell me what should I apply here?
Mesh analysis.
Yeah, but what law?
Oh, KVL.
KVL. So we are going to find the KVL here. If you want to find the KVL here and the current is flowing, so you can say this is plus, minus, and this is minus, plus, current is flowing. I current, I'm talking about I is going through the circuit. I is going through the circuit. I is flowing through the circuit. So plus, minus, plus, minus, plus, minus. Now, how many voltages? 1, 2, 3, 4, 5 voltages, right? In this loop, there are 5 voltages. Now, if you start from the 15 one, then you see this is, if your starting point is here, okay, if you start from here and then go and like come back here, if you go this way, the loop, outer loop, then the what will be that? And starting point, if you start from here, so 15I, the 15I is what? Plus or minus voltage drop. So we can write just according to our formula, minus 15I, and then 50 volt is plus or minus 50 volt.
Plus
50 volt. Like this way, if you go, please take a calculator so that it will be easier for us. 10I, then 100 is a minus 100, and then you have 25I. So this is minus 25I and equal to 0. So from this equation, you can find the value of I equal to what? So can you tell me that? What is the answer?
-1.
I equal to minus 1 ampere. Okay, if I equal to minus 1 ampere, let's substitute this I over here. This is the I where we have to substitute minus 1. So if you put here minus 1, then it will be minus 1. If you put minus 1, then you are getting what? You are getting 75 volt. So 75 volt will be the Thevenin. So you can write here, this is 75 volt. So this is our first part. A is done. That is, you have developed the equivalent, Thevenin equivalent. Find the terminal AB for the figure how much power will be delivered connected. Now this is first part, is a Thevenin equivalent you have done. Now you go for the second part and third part, that is B and C. That's the next step. Now this is what you got, the Thevenin equivalent circuit. So let's go for the second part. Go for second part. Then what will be the B and C? Let us see. Now when you go for, if you have no question, then we can go for question number B. If you go for B, B said a 50 ohm resistor, if you connect a 50 ohm resistor in this terminal, that is here, if this A and B, you go for a resistor of 50 ohm. If you go for a 50 ohm resistor here, okay, then what will happen? Then you have to find how much power, how much power this 50 ohm resistor, 50 ohm, I'm writing here 50 ohm, okay, 50 ohm resistor, how much power will be consumed? That is the question now. And now it is very simple. 50 ohm can consume what? Now, if I say power by 50 ohm resistor is what, then you will say straight away, what formula is that? The formula will be the current flow through that I, and then what will be the formula? Formula will be I square
I2R.
I square R. So I square into R, R is 50. So if you can find the value of I, then you can find the answer. You know, find I. Okay, if you can find I, can you tell me what will be the I equation from here? Can you tell me? Any one of you? Yeah. Anybody can tell me what is the I? I will be what? This
Sir,
is
V
the
by
one.
R.
V by R. V by R. What is V?
75.
75 divided by R is the summation of the two
12.5
resistance.
plus 15.
Excellent.
Yes, sir.
So
On X
12.5.
1.2.
Yeah, 12.5 plus 50. So you should write here 75 divided by 12.5 plus 50. 50 whole square into 50. What is the answer? Okay, you said 1.5 or whatever. If you did a square of that
No, sir.
into 50, what is that?
Yes, sir. 72. Final result.
Yeah, final result 72 watt. So this is first part. Part B is done. How much power is absorbed or delivered to the resistor? This is the power delivered to the resistor. Now B is done. Now if you go for C, you can easily find what is the C value. If it is the 12.5, if the resistance now, if you change this resistance, not 50, rather you change it to 12.5 ohm, then your answer will be what? That is the question. So P 12.5 ohm is very straightforward. Again, the I square into 50. I square into what? R is what? R?
12.5.
Right. R is 12.5. So your current will be in this case 75, and this is not 50. This is 12.5. Instead of 50, we are getting now 12.5. So it will be 12.5 and 12.5 plus 12.5. Okay, the whole square into 12.5. Now you can find this answer. What is the power?
Yes. 112.5.
112.5 watt.
5.
Yeah. So 112.5 watt. So you can see a different resistance at the load terminal. If you put, you see power is delivered, different power is delivered, right?
Yes, sir.
Okay. Now 12.5, if you go for different type of resistance, different type of power, you can see. In our next lecture, lecture 13, day after tomorrow, do you know what will be the title? I told
Yes,
you.
sir. Maximum power.
Yes, maximum power delivered or maximum power transfer, same thing.
Yes, sir.
This is what is the thing we will see next class. I can say now, this is more than that. That means if the load is 12.5 and 50, then 12.5 more power can be delivered if the resistance, if the load value is 12.5, then more power can be delivered, right? Then 50 ohm, then 50 load. 12.0, you can deliver more power to 12.5 if the load is 12.5, but if the load is 50, then you can deliver less power than the 12.5. You understand my point?
Yes, sir.
Okay, if you see another one, let's say 25 watt, 25 ohm, P25 ohm, you can see there will be another watt. So different resistance will give you different watt, and you have to find at what resistance the output will give you maximum watt. Among all the wattage, you have to find out which one give you the maximum power. That one we are going to see on in the next class, maximum power transfer theory. There we will see. But the idea is this. So this is one of the application of Thevenin's theorem. So Thevenin's theorem can help us to find actually what will be the maximum power, at what load the maximum power can be transferred. That one we are going to see in the next class. But the idea we can get from here. You see, this is the complex circuit. But what we do, we can convert into equivalent Thevenin circuit. After that, you can connect the resistance value here, whatever value, your 50, 25, 12.5, different value. You don't need to go back to the original circuit again and again to do the power calculation. But in one shot, you got the equivalent circuit, and then you can calculate your power easily from this circuit, right? So this is the one of the application of Thevenin theorem in order to find the maximum power transfer. This is why that maximum power transfer and this one will be combined together. Okay, that's what we'll see in the next class. We are not going to talk too much about it. Today we are going to talk about only the Thevenin's theorem. Now, if you go with this Thevenin's theorem here, this is another problem of Thevenin's theorem, and also definitely it is a little bit critical problem. So we are going towards the critical problem. So this is a little bit more critical. All what you have to do, you have to take the Thevenin's theorem for this complex circuit. Thevenin's theorem you have to find for the whole shaded area. Then a shaded circuit, actually you have to get the whole the shaded circuit except the white part. Except the white part, rest of the part, you have to find the Thevenin equivalent. So if you want to find the Thevenin equivalent for this shaded part, then how can we do it? Let us see. First thing is our solution will be a equivalent Thevenin circuit you have to develop. Equivalent Thevenin circuit should be look like this. So here is A and here is a B. This is your R Thevenin, this is your E Thevenin. That's what you have to find. Now what is R Thevenin, what is E Thevenin? What you have to find first, E Thevenin or R Thevenin from this example?
R Thevenin.
Right, because it is an independent source, not dependent. You know that. So dependent or independent source, you have to first find the R Thevenin. If you want to find R Thevenin, you know that by this time that what to do with this. We have to first take it off. This resistance, take it off. Then the terminal A and B is there. Okay, terminal A and B is there, and terminal BA you can take it out this side. Terminal B you can out this side. So you can say that terminal B is here and terminal A is here, and this is A and B terminal. In between you have to find the resistance. But you want to find the resistance, what to do with the source, that 72 volt source, what we should do?
We should short it.
Yeah, we have to deactivate by shorting this, because this is a voltage source. So we have to short it. Now, if you short it, then you have to find the value of RAB, where A is this point and B is this point. And just taking the point out, after taking off the RL resistance in the middle, you take it off because Thevenin theorem said take the RL out and AB terminal is free. Now you find the resistance across AB terminal like that. Now, if I, for the R Thevenin, if I redraw the circuit like this, then you can say, you can look at it, you can see this is coming like that, coming like this, coming like this. And you come here and you join these things to point. And this is the voltage source is shorted, and you're getting like this. At this point, I look, this is the AB point, because in between RL is taken out. So this is your AB point. What I did, I took the point outside here, A, and I took the point here, B, so that you can understand easily. So what we can do, we can take it off like that. Then circuit will be something like this. I think all of you understand. Can you tell me what is the resistance here? What is the resistance here? This is 6 ohm, right? Oh, you cannot see that thing. Just a minute. Can not come. Just a minute. Can you see now? Yep. Okay, this
Yes,
is
sir.
6, this is 6, this is 12, this is 12 ohm, and on the left hand side is 3 ohm, and this one is 4 ohm. Okay, so do you get it now?
Yes, sir.
Okay, this is what the circuit should look like. Now we have to find, ultimately we have to find the RAB. Now all of you, I think, look at this short circuit path. I'm talking about, can we squeeze this into this or not? I'm talking about, look at it carefully. If I draw this line as a red line, this red line, can I do it like this? Let's say this is C and this is D point. The C and D point, can I short it like this instead of this gut? If I take it off, can we do that? C and D can be shorted in this way, can do or not?
Yes, we can do that.
If you do that, then I have done it, and I'm going to wipe out this part. Then this part I'm taking it off, because I have already internally I have shorted instead of externally. So the other Jihad, who is answering, is the other guy Burhanuddin is answering, or Jihad is answering? Who is talking? Is Jihad?
Yes, sir.
Okay, Burhan, do you
Yes,
get
sir.
it? Okay, if not understand, please let me know. Okay, now look at it. If you get something like this, the RAB will be now very simple. If I say RAB equal to what, then what you do, C and D, if you squeeze the C and D, if you squeeze means this 2 point, you squeeze. If you squeeze this 2 point, then the circuit will be like this. This will be like this. This is C, and this will
Yes,
be
sir.
like this.
6 and 3 parallel, 12 and 4 parallel.
Right, that is what I wanted to say. This, and this one will be coming this. This is your A, this is your B. So this will be 6 ohm, this will be 3 ohm, this will be 3 ohm, and this will be 12 ohm, and this will be 4 ohm. Right, this is what you can see. And then what will be RAB? Then only one resistance, you can say A and B. RAB is coming here. What will be this value then? 6 and 3 parallel, and 12 and 4 parallel. So RAB will be what in that case? RAB means, R Thevenin means RAB will be in that case 6 and 3 parallel, 6 and 3
2,
parallel.
6 and 3 parallel 2, and 12 and 4 parallel 3. 2 plus 3, 5.
Okay, good. So it's 4 plus 4, 3. So you're saying this is 2 and this is 3. So 2 and 3 is 5 ohm. So your 5 ohm resistor, 5 ohm is the Thevenin equivalent. So your Thevenin resistance answer here will be 5 ohm. So it is 5 ohm. So that's the answer we got for R Thevenin. Burhanuddin, do you get it?
Yes, sir.
Good. I think it should be fine. If you understand, then we can jump to the next thing. So our 50% task is done. That is R Thevenin. Now our next step is to find the E Thevenin. E Thevenin will be what? Now if you want to find E Thevenin, then what I do, I just delete the R Thevenin because you already understand it. So I'm taking it off, and we are jumping to R Thevenin, E Thevenin now. Okay, R Thevenin is completed. Now the E Thevenin, if you want to go, then what to do? Then this source cannot be deactivated. Source must be active, and you can see here the A and B now. You have to find the voltage across the AB, VAB. E Thevenin means this resistance is taken off. This resistance, you understand it, this resistance is taken off. That is the Thevenin theorem. And what will happen then? This A and B, this two terminal, this is your B terminal and this is your A terminal. This A and B terminal, which is, I think we can say, this is positive terminal and B terminal is a negative terminal. For example, this is positive terminal, this is negative terminal. This is B. And let's say this is C and D, should be fine, no problem. So This 2 point, we have to find the voltage across these 2 points, which is VAB. Now, if you want to find VAB here, if you want VAB here, so what will be VAB? Try to get my point. Okay, so VAB will be what? Now, one thing you can understand from here, I can show you that this current is coming into this, and this current is dividing into 2 current. One current is going through this, another current is going through that, for example. So this current dividing into 2, just taking you the easy way to find. This is, let's say, or one thing you can do, you can straight away instead of this, you can easy way you can do. If you want to find VAB, this is C, A to C, C to A to C, sorry, this is C, A to C, and C to B, like that. VAB will be VAC. Okay, I can say the VAC because if you say the current is going through this and this is your plus minus. This is your plus minus. So our A is positive and B is negative. B we're finding. So if you go this way, so VAC, if you say VAC plus BCB, this is what we can say. Or if you go for other way around, because in the middle there is no current flow, so, or you can say VAB can be like this also. Another equation also we can write, either one, no problem, which one you understand. If you say this point A and D and D and B, so VAB can be written here VAD plus VDB, like that. Now, if you say this AC, it is the current flow from C to A, so you can say minus VCA, and this one CB is okay, VCB is okay. But if you write the other way, then it is negative, because AC, so if you write CA, it will be negative, like that way. And this one also same, because the current flow in this way, I'm just going to say current is flowing and flowing. This is the current actually. If you say this is current flowing here, I1 current, then I1 is going through this one, also I1. And this current flowing through the resistance is I2. If you say this is I2, that means this current also I2, because it is the same current, same current is flowing. Try to get my point. Same current is flowing through this, and let's say this orange, the same current is flowing through this, right? You should understand, because in the middle the resistance is off. If there is no resistance, then the current will be flowing, divide into 2. One is the green current, one is the orange current. This is for again joining together, and they are coming back to this. I think the red current is coming back to this. They're joining together and coming back. Like that is the, like a Wheatstone bridge, like sort of things. Okay. Now, if this is the scenario, then what will be the voltage in this case also? VAD. So you write VAD will be as it is, and that one will be, if other way you go, VD, then it will be minus VD. Minus VBD also you can say. So either one. Now, you can find the voltage for this or voltage for that, and you must get same value, either equation you follow. Now, how to find the VCA or VCB? Let's say VCA, VCB, how can we find it? Do you have any idea? VCA, VAD, VCB, VBD. Anyone, I think I'm not telling you, forget about this thing. You just imagine we are not going to. We are going to solve this one. Our target is to find VAB. Either you can use this equation or you can use that equation. Doesn't matter. But any equation, both equations will give you the same answer. Only one is enough. Now let us go for this one. So what will be the VCA and what will be the VCB? How can we find it?
Sir, we can apply mesh analysis twice. I mean, two loop.
Isn't more easy way? Are there any easier way? Because this is just try to think. Look, I'm giving some hints. If this is the point, which is what is the voltage from here to here is what is the voltage?
72.
72. So if this node point come here, and if this node point come here, then voltage between C and D will be what?
72.
72. VCD also 72 volt. Right?
Yes, sir.
If it is VCD is 72, then we can find the VCA or VCA or VCB. We can easily find it. What law? What rule? Some rule can be applied. What rule?
Sir, I is equal to V by R.
Okay, I you find and these that slowly. What can we directly say the law rule? What is the name?
Sir, another deal we can voltage divider rule.
Exactly, voltage divider rule. Exactly, voltage divider rule can give you the answer directly. So if you say the VCA, voltage divider rule said 72, the total voltage divided by summation of the two resistance, 12 and 4, right? 12 plus 4 into the resistance value. What is that? 12 is giving you the VCA. Do you understand it? This is your VCA. Yes or no?
Yes, sir. Can you scroll it up, please, sir?
Okay.
Yes, sir.
You can see these things. All right, now 12 plus 4 into 12. If yes, then what will be the VCB? Can you tell me? Same way. VCB in the left hand side, on the left hand side from here. Okay, VCB is, you understand VCB? VCB is this voltage. Again, same thing. Again, the voltage divider rule on the left hand side, because you have applied the voltage divider rule to the green side.
7
and yeah, the orange side one you have to. So go 72 divided by what?
72 into 6 divided by.
I'm going to do the orange side, then you can get it. Orange side with the orange pen. Yeah, 72 divided by
into 6.
No, divided by what?
Okay. Divided by 6 plus.
You cannot see that. Okay, I'm just going to take it out.
6 plus 3, it's maybe.
Okay, 6 plus
yes, sir. 6 plus 3.
3. 6 plus 3. Good.
Into 6.
Into 6. Excellent. And this gives you the answer directly. So what is the answer coming there? Minus, what is this voltage? 72. You should do that. Hey, Jihad and Burhanuddin, both of you should have a calculator, I think. This is a bit critical problem. If you can solve it and you are clear.
Minus 6.
This one is minus 6 and the other one?
So total, I said.
Okay, can you tell me individually what is that?
Oh, okay,
minus?
Sir, first one is minus 54.
Minus 54. And the second one is plus?
Second one 48.
Second one is what?
48.
28. So this is 54.
48.
This is 48. 48.
Second one is 48.
Yeah, 48. So 54 and 48 minus, that is minus 6. That's what you told me, right? Minus 6 volt. Good.
Yes, sir.
So this is minus 6 volt. If you get, then same way, if you do this, you get the same answer, because VAB, if it is VAD, so AD will be what? AD is this one. Okay, this is 4, right? So 72 divided by 12 plus 4 into 4, and minus 72 divided by, what is the equation? BD will be 3.
Yes, sir.
3
72
plus
by
7, 6 plus 3, right? 6 plus 3
yes,
into
sir.
what?
6 plus 3 into 3.
Into 3.
3.
And are you getting the same answer or not? Now you check. Are you getting minus 6 or not?
Yes, sir. I get minus 6, sir. 18 minus 24 is equal to
Okay,
minus 6.
minus 6 volt. So either one should give you minus 6 volt. Only the thing is conception, your understanding. If you understand, that is great. You said, yeah, I understand this, I also understand this, good. But the answer is one answer. In the exam, you don't have to write twice. You have to follow only one. That should be fine. Okay, so your answer here should be minus 6 volt. This is plus, this is minus, sign is okay, and a Thevenin is okay. The answer will be minus 6. But if your polarity you change, minus plus, if you change this polarity, then you can write there plus 6. Remember, but this polarity like this, then you have to write minus 6. Okay, so this is the answer to this problem. Do you get it?
Yes, sir.
Okay, good. Let's go to the next problem. This is one critical problem we have solved. And there is another critical and the last problem. This is our last problem. From that slide, we can understand, then we can finish it today. Then not on theorem, I think rest of the thing you know that. So let's come back to the point here. What is the question if you read? You have to find the Thevenin equivalent of the network. There are two Thevenin network, two Thevenin equivalent you have to find, A and B, where A is x prime and B is y prime. So first you go for A. If you go for A, then you have to go for the Thevenin equivalent, where this is your Thevenin voltage, Thevenin resistance R Thevenin, and this is your Thevenin voltage E Thevenin, and A and B. First of all, you say x prime. So you write here x, and this is x prime. This is the point we are going to take. That means this point. This is the point x prime. We are first finding this thing. So x is here, and x prime is here. For example, you can just think like that. This is x, this is x prime. Of these 2 points, we are going to find the Thevenin equivalent at. So if you go for this, you can all do one thing. What is the value of the Thevenin resistance first? I am asking you to do it. After that, you have to find what is the E Thevenin. Can you try yourself first? And then I'll show you. You just go ahead and check whether you can do it or not. Go.
Sir, should we consider the right part as RL? I mean, we should take it out.
Yes, Jihad or Burhanuddin, could you find the answer?
Sir, should we consider the right part as RL and take it out?
No, there is no RL here.
Oh, okay,
Just
sir.
assume this is, that's why I have extended the XX prime
Eight-
outside.
8.57. Sir.
Okay, how you found
Sir.
R Thevenin, let's say.
So 40 plus 20,
So
60.
you take it off,
and
right? You take it off.
Yeah, yes, sir.
And you shorten it.
Yes, sir.
Okay, in that case, the R Thevenin equation 80, your 10 and 50 is parallel. And 20
Sir,
and 40 is 60.
should we off 50 ohm?
No, no, no. That's why I extended the XX prime so that you understand that you don't need to take it off.
Okay.
Got it? So if it is, okay, if it is told, then it should be shown that this is a variable or you have to take it off, like sort of things. But it is not the thing you have to take it off. If you take it off, then what happened to YY prime? Will you take the 1 ampere current source off? Or 40 ohm resistor off? No. This is like this way you have to, okay? In that case, you can see these two will be in parallel and these two will be in series because this is taking off, right? Open circuit, and that will be parallel with this 50, 40, 10. Like, so you can say that this guy is coming here as a 20 plus 40 is in parallel with 50, which is parallel with what?
10.
10, good. Which is parallel with 10. So this is the parallel sign. You can understand the parallel sign is this. Okay, now that means this is 60 parallel 50 parallel 10. This is the thing. Now you tell me what is the best answer. Now, if you understand, it's okay. If you don't understand, tell me.
Yes, sir, I understand.
Now, what is the answer?
So 7.31.
7.3 ohm. Okay, 7.3 ohm. If this is 7.3 ohm is the resistance, Thevenin resistance you can have. Now, your next job is to find V Thevenin. V Thevenin means you have to keep the thing as it is. You cannot say it is gone. Rather, you can keep it like this. Okay, then you take it off. All the sources are active now. If all the sources are active now, then what is the V Thevenin? If you want to find the E Thevenin means this is your target now. E Thevenin, what is that? Now, if you want to find E Thevenin, then what to do? Then E Thevenin means open circuit voltage E X X prime. This is your plus, this is your minus. Imagine this is plus and this is minus terminal. That means this is plus terminal, this is minus terminal. So V X X prime or X open circuit voltage. That one you have to find it here. If you want to find that thing here, what does it mean? It means this is nothing but the voltage across what? Across the 50 ohm resistor, right?
Yes, sir.
Okay, so you have to write 50 into, if you say the current flow through this circuit is I, then 50 into I, that's it, your Thevenin voltage. Now, if you can find the value of I, you can find the Thevenin equivalent voltage here. Now, what is I? How can you find? This is just from circuit solution. How can you find the I? Hey, anybody can tell me. If this is a circuit given to you and ask you, oh God, can you find what is the current flow through the 50 ohm resistor? A circuit given. What method, what law you apply and find it? Any method, any law, you know. What is your idea? What method will be easier?
Sir, we can do source transformation. We can
Okay,
do nodal analysis.
Absolutely good. We can go for source transformation.
Mesh analysis as well.
Mesh analysis we can do. Okay, either mesh analysis or source transformation. Either one can give you the solution for this. You go for mesh analysis. This is the mesh current and this is the mesh current. I1, I2, I3.
I3 we already know.
I3 already know. What is the I3 you go to?
Sir, -1.
Good. I3 is -1. So you can find from I1 and I2. If I1 and I2 you know, then what will be I equal to? I will be what?
Sir, I will be I1 minus I2.
Right. I1 minus I2. I2. So you mesh current, if you write the equation, from the equation you can find the value of I2 and I1 and I2. And then you substitute the value here, you get the value of I. Because I3 you already know, -1.
Yes, sir.
So if you can find the value of I from here, that I you can substitute here, you can get the value, and that will be your EXX, which is nothing but, EXX is nothing but E Thevenin, right?
Yes, sir.
So you can get the answer here like this. So all you have to do is, you have to do the mesh analysis. Do you want me to do it for you now?
No, sir.
So this is how you can easily solve the problem. This is the way I can show you. You can do it by yourself. Okay, this is part A done. Part A was the XX prime. Now we are going to go for part B, Y prime. I'm going to show you Y prime, and then you can also, same way, you can solve the problem. Now let us go for part B, how to solve the part B. Let's bring it back again here, and then we can see the part B part. So part 1 is done. Now we are going for part B. The part B said what? The same thing. You have to find the Thevenin equivalent circuit for this time. It is not XX prime, rather it is Y prime. So this will be your Thevenin voltage source plus minus, and E Thevenin, and this is your R Thevenin. Okay, now if you go for this, this will be plus minus. This is R Thevenin, Y Thevenin. This is the one we have to find. Now, in this case, again, I'm going to show extending the Y here, Y prime here. So you can understand this is Y, this is Y prime. You don't need to cut, or you don't need to take out anything. And this is, okay. So this is the thing. Now you have to find the R Thevenin first. You have to find R Thevenin first. You have to find R Thevenin first. What to do? You have to deactivate the source first, right?
Yes, sir.
Okay, if you want to do deactivate, the voltage source should be what? Will be
short circuited.
Short circuited, and this one will be open circuit.
Open circuited.
Right? Okay,
Yes,
if you look into this through this one, R Y prime, which will be nothing but R Thevenin, and that will be equal to what? Now, what is your idea? R Thevenin will be equal to what?
So the same as the previous one, sir.
Okay, tell me how.
So 10 and 15 is in parallel, and then this is parallel with 16, 20 plus 40.
Okay, okay. Do you agree? Who's saying? Jihad saying this thing?
Yes, sir.
Yes, sir.
Okay, and Burhanuddin, what is your idea? Same thing.
Sir, same, sir.
Same. Okay, now look. If you do this, these two are parallel, right? This is what you understood. Yes or no? 10 and 50 is parallel or not?
Yes, sir, parallel.
Yes, sir.
Okay, both of you agree. Now, these two are parallel. And that one, this parallel combination is in, hey, listen. Hey, what happened? You're listening to me?
Yes, sir, yes.
Okay, this parallel combination, get one reason. That parallel combination is in series with 20, right?
Yes, sir.
So that one will be in parallel with
40.
40. And that is the answer, isn't it?
Yes, sir.
So the thing you have to write is 10 and 50 is parallel. That will be in series with 20, and that whole thing you are getting will be in parallel with what?
40.
40. Now you find it. What is the answer? Now, you think twice, you understand or not. The 10 and 50 is parallel, and which will be in series with 20, and the whole thing will be in parallel with 40. Hey, Jihad, I think brain short circuited or Burhanuddin.
No, sir.
Okay.
Sorry, sir. And the answer is
Yeah, tell me the answer.
16.58. 16.58.
Both of you got the same answer.
I'm calculating, sir.
You find it and see whether getting the same answer or not. What is the answer you get? This is very important. You need to know. Okay, I think who found it? Can you break down the value? 15
Okay, sir.
is 60. 60 plus 20. Oh no, it's not 60 plus. I'm sorry. What's the parallel value?
Oh, sir. This is, oh, sir. 10 plus 15 is equal to 7.14.
Yeah.
Sir, answer is same, sir. 16.58, sir. I have
Correct.
got the yes, sir.
Same answer?
Yes, sir.
Or you think, sir, it's another boring job? You are showing it again.
No, sir. No, sir.
Okay, good. If you got the answer, then we got the answer. It is 16.58. So the answer is, this is a very simple thing. All you need to understand the way I'm doing. Okay, so this is 16.58 ohm. 50% of the solution is done. Now another 50% we have to go, and that is nothing but E Thevenin. So your E Thevenin is what we have to find now. E Thevenin equal to what? Now if you want to find E Thevenin, then we are going to take it off. All the sources are active now. No inactive. All the sources are active, and this part is done. So we are not considering this thing that part. So we have completed the R Thevenin. Now we are going for E Thevenin equal to what? You know, to E Thevenin. E Thevenin means the voltage, open circuit voltage. That is your E y prime. This is plus. This is minus. Got it? Open circuit voltage E y prime.
Yes, sir.
The EYY prime is the voltage. If you say the current source, or it can be, if you can up to this, it can come up to this, up to this. That means it is the voltage across what?
40 ohm resistor.
40 ohm resistor. That is the way you can find the value. So what is the 40 ohm resistor? That means it's a very simple. If you assume the current flow through this is I, again, then your EYY prime will be equal to 40 Ohm's law, 40 into I. It's very simple. This is plus, this is minus, right?
Yes, sir.
So this is green positive, this is negative. So EYY prime is 40I. All what you need to know is the value of I. So you can get the answer. What is I equal to is our analysis now. How to do? What do you think? How can you do it? If I ask you again the same way, if I ask you what is the value of I of this circuit, can you find it? What method? How you do?
Sir, can we do mesh analysis as the previous one?
Like the previous one. You can do it in the mesh analysis. And since previous one we did the mesh analysis, this one also you can easily find mesh analysis. So that this is I1. If you say like this one is, for example, this one you say I1, I2, I3, and I3 value you know which is -1, right?
Yes, sir.
And I will be what? I3 is -1. I will be what? This is I1, this is I2.
Sir, I will be
go.
I2 plus 1.
I2
plus 1.
I2 minus I3.
Yes, I2 minus I3. Yes.
That one you tell me, then you can find the value, substitute the value. This is I equal to, sorry, this is I equal to, hey, you understand what he's saying?
Yes, sir.
Okay, good. So I will be equal to I2 minus I3. I2 minus I3. Now I3 is minus 1. You can substitute the value of I3 minus 1. This is a plus 1. But you have to find the value of I2, and I3 is given already, or I1 also you have to find it. Then you find ultimately you are using this value. Once you know the I, then you can substitute the value I here and you get the answer. This is what last time also we solved the problem the same way. But your friend told me there is another way we can solve also. What is the method? You told me last problem. What is that? Another one. Hey.
Yes, sir. Sir,
What is
I
that?
told source transformation. Sir.
Source transformation. So that is another way you can also find this solution using source transformation. Good. Source transformation, if you do, this is also you can do it this way. This voltage source you have to convert into current source. Then that current source you combine together is another current source coming. Then current source can be combined with the voltage source again. That voltage source is going to be converted into current source, and that current source and this current source are combined together, and
yes,
one current division rule can be applied to find this current directly. You understand it?
Yes.
Okay, I think source transformation also will give you the same answer. Most important thing, the value of I you are going to get, either you apply the source transformation or you apply the mesh or apply the node or whatever you apply, ultimately you are going to get the same answer. That is the main thing. I value will be same, whatever method you apply. And you can find the value of EYY, that is your E Thevenin. So you can get the E Thevenin, you can get the R Thevenin, you can find your solution for this problem. Now I'm thinking that you are expert about normal Thevenin analysis. Any circuit given to you, you can easily find the Thevenin equivalent now. If the circuit is having what? Independent sources, right?
Yes, sir. Yes, sir.
Okay. But if the circuit is having dependent source, then it's a different issue, and that one you already know by this time. So for the last, this is the solution for the last problem of our Thevenin equivalent, that what we have seen. And the last slide is problems with dependent source. That's what you already got the flavor, what I mean. And after that, there is a thing for this slide is the dead end of the slide. So that is the end of Thevenin's theorem, that what we have started and what we started today. Combined together, the Thevenin's theorem is completed. Now, that's all about the Thevenin's. You have any question, or we are going to off the session for today?
Sir,
Yeah.
can I say something? Yes, sir.
Yeah,
Sir,
related to this or something different?
Yes, sir. Yes, related to
if
this.
related, then
Thevenin's
you
equivalent circuit.
talk
Yes.
about it, please.
Yes, sir. Sir, if we have a voltage source in series with 15 ohm resistor, if 50 ohm resistor, if we have a voltage source parallel.
Okay, you're just telling me if a voltage source, if we have a voltage source with 15 ohm resistor in what?
15 ohm resistor in parallel. In series, sir. Sorry, in series.
Okay.
In series. Okay.
In series, then what happened?
Then, sir, while
this is 15 ohm.
Yes, sir. This is 15 ohm. Oh, sir, I'm related it to the last problem as we saw.
Then we can see go to the last problem.
Yes, sir.
Here, this one or previous one.
Yes, sir. This one. This one, sir.
Why is 50?
If we, yes, sir, in the middle, sir. 15 ohm. 50 ohm. Yeah.
Oh, 50 ohm. Okay.
Yes, sir.
Okay. Which problem? It is A or B?
A, problem A.
Okay, this is A. Okay, no problem. Go ahead.
Yes, sir. If we have a voltage source in series with 50 ohm, then while calculating the RTS, should we take it out or what, sir? I didn't get. I mixed up with RL.
Okay, I got it. If you're talking about in series, means if the voltage source is here, is it?
Yes, sir. Yes,
plus
exactly.
Minus. Yeah, if it is in plus and minus over here, then you must when you find the R Thevenin, is it?
Yes, R Thevenin.
Or when you listen, when you find the R Thevenin, then the answer will be same, because this voltage source will be what? When you find R-Thevenin, voltage source will be
Shorted.
shorted. The equivalent means shorted. Then R-Thevenin will be same, isn't it? No change.
Okay, sir.
Got my point?
Yes, sir.
All right. Now, when you go for E-Thevenin, that time, yes, this will be affecting the thing. Then what will be the Thevenin voltage or E-Thevenin equal to? Then this will not be the equation. Some sort of things should be modified. What is that? 50I. Look, you can tell me what is that?
So we should add 50 volt
It
in
is
that
what?
equation?
This is 50 volt. Okay. If you say this is 50 volt source, that is what you are saying, right?
Yes.
Okay. If it is a 50 volt source, then you have to add this 50 volt source plus minus. Then this is plus, this is minus, right? This is plus, this is minus, and this is plus and minus voltage source value. So you have to add this guy as plus 50 volt. Get it now?
Yes, sir. I got it now.
Now I value you are going to find, and then you can
Yes.
go for it. Whatever the value you get I, you can easily find the E-Thevenin and that E-Thevenin value. That's okay.
Yes, sir.
All
Got
right.
it now.
So any question? If no question, then we are going to finish our class for today. Should be fine?
Yes,
All
sir.
right. Good.
After this, we are fine.
Yeah, up to this fine. Then we'll see next. Thank you very much for your attending the class. Thank you very, very much. I appreciate you. Thank you. See you next
Thank you,
class.
sir.
Okay.
Assalamu